Hello, namaskar, vanakkam. Welcome to CBSE with Sudhir, where we are going to do the next chapter, the chapter on electricity and magnetism, which is part of your class 8 textbook, Curiosity. Okay, now I do hope all of you have this particular textbook. So this is called Electricity, Magnetic and Heating Effect. फैसिनेटिंग चैप्टर, मजा आएगा. अपने नोटबुक और पेन साथ में रखो, बुक को भी ओपन करके रखो so that we can have fun together. So first let me tell you what will we study in this particular chapter. So the first point is, if we do not have an electric lamp while making an electric circuit with an electric cell, is there any other way through which we can find out if current is flowing in the circuit? We have already studied all this in class 7, right? About making an electric circuit, etc. Any doubts? Look at the class 7 science playlist. Now, here, if we do not have an electric lamp, is there any other way of finding out that whether current is flowing in the circuit or not? This is one thing that we will discuss in this chapter. The second one is it possible to make temporary magnets? I have discussed magnets chapter in class 6 also. A very fascinating chapter, one of the videos which has got the maximum number of views. The temporary magnets. Can we create a temporary magnet? The whole concept of magnetism is what we are going to study in this chapter. Then we can generate heat by burning fossil fuels and wood. If we burn wood, we generate heat, when we are feeling cold. But is it possible to generate heat in various electrical appliances? Is it possible to generate heat, for example, in this toaster? This we know. Is it possible to generate heat in this particular electrical appliance? Fourth, how do we know if a cell battery is dead? Can all cells and batteries be recharged? For example, where did I keep it? Yeah. For example, you have these kind of batteries, right? This you use it in a TV remote, in AC remote, etc. We use this AAA battery. The bigger ones are the AA battery, right? Now, is it possible to recharge this? This is not rechargeable. These are dry cells which are used in the TV remote, AC remote. After a month or two, they will get discharged. You need to throw them out and replace it with a new battery. But something like the mobile battery, it kind of has a longer life. Whenever it is down to 15% or less, you put it on charge so that it gets charged back to 100%. So that is the kind of mobile battery. Or in various other appliances like an inverter, the battery keeps getting charged after the current comes back, after the electricity comes back. So these are some of the things we are going to study in this chapter, and I promise this is going to be real fun and exciting. Let me tell you, for those of you who have been asking me about the question bank, which question bank to buy, the Oswald book question banks is what I recommend. The link to buy it on Amazon. This is the book that I am talking about. This is the book which is called One for All Question Bank Class 8 Science Curiosity. Similar books are there for social science, part 1 and part 2, English, mathematics, Hindi, Sanskrit. So you can look at it. Where do you buy this? Follow this link which is given in the description box. Alternately, you can go to oswaldbooks.com website. Okay, there if you use, in fact, that link also I will put in the description box. Otherwise, oswaldbooks.com, you just go and look for One for All Question Bank Class 8 Science or any other subject. What you should do is to use this coupon code, because this coupon code will get you additional discount. Because I'm an author there, I get this coupon code which you can use for your purchase of any book from Oswald Books. Okay, this is on the website. This link is for Amazon. Okay, now let's look at the story which is there in your textbook. At the school science exhibition, Mohini and Akarsh went from one exhibit to another, eagerly exploring different models, asking questions and taking notes. Like all science exhibitions, which are very fascinating, you look at different models and you feel very fascinated by that. Okay, now they were fascinated by the working model of a lifting electromagnet. Now this is an electromagnet which has been created, okay, by their senior, whose name is Sumana. Now what happens is that she has put a magnet out here which is able to attract all these kind of iron clips towards it, right? It is able to attract all the clips. This is Sumana's electromagnet. Now in it, instead of a hook like a typical crane, there was an iron nail wrapped with a wire. This is an iron nail wrapped with a wire which was connected to a battery. So there was an electrical circuit which had been completed by Sumana. Okay, now this was completing the circuit through the iron, and there is this coil around that particular iron, and from there the hook has been there, right, which is acting like a magnet. This has, because there is electricity passing through the iron nail, so this has become an electromagnet, and it is able to function like a proper magnet. Okay, so in it, instead of a hook like a typical crane, there was an iron nail wrapped with a wire which was connected to a battery. When Sumana closed the circuit, that is, she switched this on, the nail picked up iron paper clips like a magnet. So this is what it was doing, and they were very fascinated by what they saw at Sumana's stall at the science exhibition. Now what happens next? Sumana switches off, that is opens the circuit, that is, from closed it opens, that is, now there is no power flowing through this. So the moment she does that, this stops behaving like an electromagnet. When she opened the circuit, the clips fell off. Mohini and Akash were surprised because they knew that magnetic materials were attracted by magnet and that iron was a magnetic material. But in Sumana's model, there was no magnet, only an electrical circuit, right? This is what they saw. So what is the explanation of what Sumana's electromagnet model was all about? The compass needle is a tiny magnet which deflects. Oh, sorry, this is 4.1. So this is what they saw. So now we will explain what Sumana's electromagnet model was all about. Let me show you in your textbook. Now this is a circuit which has been made as per your textbook, right? There is a compass which has been connected. It has been put on two nails on this cardboard. Once you connect this, the circuit will get completed. You have used these kind of cells. You know, this cell is exactly like this particular cell, minus and plus ends, and the circuit will get completed the moment you add it out here. You know, in this particular diagram, the B part, the circuit has been completed. Here the circuit is open. Okay, now what happens here is, collect a magnetic compass, an electric cell, a cell holder, two drawing pins. So you make this particular circuit, right? So once you do that, connect this wire, and you have completed the entire thing. Okay, while watching the compass needle, move the switch to the on position. That is, you close the circuit and you switch it on, right, to allow electrical current to flow through the wire. What do you observe is what is asked. Now again, while watching the compass, switch it off. What do you observe this time? Now you may have noticed that when the current flows, the compass needle gets deflected from its position. So if the compass needle is at this position, it will deflect in one direction or the other, right, depending on the flow of current. When the current stops, the needle returns to its original direction. When you switch it off, the needle comes back to its original position. There is no change in that. So as we have learned, as I said, in class 6 in the magnets chapter, the compass needle is a tiny magnet which deflects when a magnet is brought near it, and this magnetic effect can act through any non-magnetic material kept in between. So normally what happens is that when there is a compass, look at your class 6 chapter, and then you bring a magnet near it, it will deflect, right? So the magnet is having that effect. But here there is no magnet. So what is happening? It is the electrical current which is passing through the iron, okay, that is having that kind of an impact. So let me explain this here. So the compass needle is a tiny magnet which deflects when a magnet is brought near it. But why does the compass needle deflect when the current flows through the wire? The deflection indicates that the current carrying wire has a magnetic effect on the compass needle. This is the phrase that you need to understand. It is creating a magnetic effect on the compass needle, even though there is no magnet near it, but it is the electrical current flowing is creating a magnetic effect. That is what is really happening out here. Now, when electric current flows through a conductor like a wire, listen to this carefully. When electric current is flowing through a conductor like a wire, when it is flowing like that, it produces a magnetic field. It is creating a magnetic field around it. Okay, so anything that like a compass comes close by, it will start acting accordingly around it. This phenomena is known as the magnetic effect of electric current. You understand? That is, when there is a current going through this wire, it will also create a magnetic field, right? So when this compass is coming in the under the influence of the magnetic field, it will start deflecting, very similar to, instead of this, if there was a magnet which was brought close to this compass, even then it will deflect, right? So the same effect is taking place as a result of the electricity that is passing through this wire, this conductor. The moment you switch it off, it is gone. The magnetic effect is gone, zero. The compass will not, there will be no impact on the compass, there will be no deflection. I hope this is clear. The region around a magnet or a current carrying wire, when its magnetic effect can be felt, such as by the deflection of a compass needle, is said to have a magnetic field. The magnetic field disappears when the current stops flowing, what I just now told you. Is this clear? Yes or no? Now, magnetic effect of electric current. Let's understand the history of it. There was a scientist called Hans Christian Ørsted in the year 1820. So we are talking of more than 200 years ago, 206 years ago. He discovered that electricity and magnetism are interlinked. They have a connection. They are not separate, they have a connection. So what happened was, a compass needle deflected when a nearby electric circuit was switched on or off, what we just now observed, right? So this is what he has also observed. That is, the moment there is a thing and there is some kind of a deflection. This is a very simplistic diagram. It will not be like that, but basically for you to get the idea. So the core principle of what Ørsted discovered was that when electric current flows through a conductor like a wire, it produces a magnetic field around it, what I just now told you. The field disappears when current stops flowing. Okay, so let's understand the definition of a magnetic field. The region around a magnet or current carrying wire where magnetic effects are felt, that is called a magnetic field. I repeat, with the region around a magnet, the region around a magnet, or if not a magnet, a current carrying wire, conductor, a conductor through which current is flowing, that area produces a field around it, and that's called a magnetic field. What are the applications of this magnetic field? It is used in electromagnets like electrical bells, जो आपके दरवाजे के बाहर घंटी है, जो कोई टिंग टोंग बजाता है. Think of it the next time while I explain this. What really happens? It is the principle of electromagnetism which is actually operating your electric bell. Similarly, your motors, different kind of motors, fans, the fan which is working, loudspeaker, major impact, right? Loudspeaker, this kind of thing is all operating on the principle of, or a motor or the electric bell. These are all operating on the principle of a magnetic field. Is this clear? Now, how does it operate in an electric bell? Let me tell this to you. You will find it very fascinating. And next time, you will observe this very closely. What happens is, the bell, okay, जो bell है यहाँ पे टंग करके बजाते हैं, what happens then? The bell has a coil of wire inside. The electric bell at your entrance to your home has a coil of wire which is wrapped around an iron piece. Okay, wire around an iron piece. Okay, when you press the switch, the moment you press the switch, which means you are completing the circuit, electricity flows through this coil, creating a magnetic field. So electricity flows, और इस coil के around जो है उसमें it creates a magnetic field. Near this magnetic field, what has been kept very strategically is a metal strip. Okay, is there a metal strip? This is a metal strip. Okay, which has a hammer attached to it. Okay, so the moment it happens, this metal strip, it immediately pulls the metal strip armature towards it और जाके टंग करके घंटी पर जाकर लगता है. Okay, so the moment you remove your this thing, the thing goes off. Then you press it again, the circuit gets completed again it will ring, right? So it again goes and hits the dong. As the armature moves towards a magnet, it moves away from a small contact screw. This breaks the circuit. So then the thing stops. But the thing is that it happens so fast that you don't really notice the break. When you press the bell, ding, 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 जैसे वो तोते वाली आवाज होती है ना, की 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 की. So the thing is so fast that you don't notice that it's actually connecting, disconnecting, disconnecting, connecting, connecting, disconnecting. It's happening at a very fast speed. So this breaks a circuit. Since the circuit is broken, the electricity stops and the coil loses its magnetism. It is no longer a magnet, so it lets go of the hammer, the armature, the metal arm, it lets go. A spring pulls back the armature to its original spot. Once it again touches the contact screw, again the magnetic field gets charged and it hits the hammer goes and hits the gong. This happens so fast, many times per second, that the hammer hits a gong over and over, creating that continuous ringing sound of the electricity bill. So this is what it happens. So the magnetic field is used as a switch that turns itself on and off automatically to keep the hammer moving back and forth. So this is the concept of an electric bell, not exactly in your syllabus, but I thought as students of physics, you should have an understanding of how these things are actually implemented in different devices. Okay, if you have that kind of a scientific bent of mind, it will help you tomorrow when you are writing the JEE examination or something, because there you will get more and more practical application oriented questions, competency based questions, and that will really help you. Okay, let's now move to the next part. Okay, we have to look at the next set of activities, 4.2 and 4.3. इनके बारे में तो मैंने भी बता दिया. खुलजा सिमसिम 4.2. Okay, now this is the activity 4.2 where you are taking a battery. This is a nail and you are wrapping this coil around it, right? So you are kind of completing the circuit through the battery, and as you can see, there are many iron clips which are getting attached, similar to what Sumana had done at the science exhibition, right? So this is what happens in 4.2. 4.3, again, you are doing this, a coil of insulated wire. Take around 100 centimeter long flexible insulated wire, a piece of chart paper, an iron nail, an electric cell, and two magnetic compasses, and few iron and clips, and you kind of put it around that. Now this is interesting because you are putting it like this, and there are two magnets that you are putting on either side, right? So when you are completing the circuit, you will realize that they start deflecting. They start deflecting. You see from here, they have moved to this side, right? So they start deflecting. So connect the two ends of the coil with the terminals of the cell as shown in figure 4.3c and observe the magnetic compass. Do you see any deflection? Again, you will see deflection. So the observation is that when current is passed through the cylindrical coil, it behaves like a magnet and deflects the needle of the magnetic compass. When an iron nail is inserted in the core of the coil, when an iron nail is inserted, इसके अंदर जब iron nail को डालोगे, then the deflection is very high. It is reflecting much more, and it's also able to attract the different clips that are there. So a current carrying coil that behaves as a magnet is called an electromagnet. For practical applications, most electromagnets have an iron core to make them stronger, more powerful. Okay, so let me just give you the explanation to this. So when current is passed through the cylindrical coil, it behaves like a magnet and deflects the needle of a magnetic compass. When an iron nail is inserted in the core, so when you put an iron nail it becomes a more powerful electromagnet. Then the coil becomes a stronger magnet and the deflection of the magnetic compass needle is much more in that case. It also attracts iron clips. When the current is stopped, the cylindrical coil loses its magnetic effect. Okay, now this is, I am hoping, is very clear because I have repeated it at least 3 times. So acha revision bhi ho gaya hoga. A current carrying coil that behaves as a magnet is called an electromagnet. This definition you should be aware of. For practical applications, most electromagnets have an iron core to make them stronger. So you see, you will have that iron core, and uske around you will put the coil, and that will make it much more strong. The same is the case with the electric bell, which I just now told you about. Now, electromagnet's definition: a current carrying coil that behaves like a magnet. That is the definition of an electromagnet. How is it constructed? Usually contains an iron core to strengthen the magnetic effect. Okay, this is the iron piece, and around that is the coil, and that strengthens the magnetic field effect of the electromagnet. It has a north and south pole. This is again something which you have studied in class 6, that a magnet has 2 poles, north pole and south pole. This is the north pole and this is the south pole. Then how can its strength be increased? By increasing the electric current. One way of doing this, by increasing the intensity of the electric current, you can increase the magnetic effect, the electromagnetism of that particular iron around which the coil has been put. By increasing the number of turns in the coil, now this is a better way. Instead of increasing the current, if you increase the number of coils around the iron, okay, then its electromagnetic effect is actually increased. Then you can also reverse it by changing the direction of the current. Instead of flowing in a clockwise, if you change it to anti-clockwise, you can reverse the pole. The north pole can become the south pole can become the north pole. The poles can be reversed by changing the direction of the current. Then this is interesting that Earth's magnetism is also a very important factor for various species, because the Earth acts like a giant magnet, because moving liquid iron inside its core creates electric current. So inside it, there is a lot of moving liquid iron, and that creates some kind of a magnetic effect. उससे क्या फायदा होता है? What impact does it have? Because migratory birds, fish, animals use this field to navigate across continents and oceans, so they are able to know. Human beings may not have that intelligence or capability, but migratory birds like the Siberian cranes, etc., because of that, they are able to say that, okay, this is a season and we can move from this place to the other place. So they use this kind of a magnetic effect of the Earth in order to determine which direction they should travel in. Then the Earth's magnetic field also acts like a shield, blocking harmful particles from space and helps to protect life on Earth. So that is another advantage of the magnetic field of the Earth, right? Before I go further, just a reminder, I want you to subscribe. It's absolutely free to this channel, to this YouTube channel, and also share the videos. You would be having classroom WhatsApp groups. If you think a particular explanation video has been of use to you, share it with your classmates in your school, with other friends in other schools of class 8, class 7 videos, class 6 videos, so that we can build a larger community here on CBSE with Sudhir. Okay, now let's move to the next part, which is talking about lifting electromagnets. I hope till here there is absolutely no doubt. Okay, let me drink some water. What exactly do we mean by lifting electromagnets? This is something similar to what Sumana's model was all about. Lifting electromagnets are strong electromagnets that may be hung to the cranes. Like you may put this kind of magnet and you may be able to lift heavy objects. The crane may be able to do that. The crane operator can control the magnet by switching the current on or off. So you switch it on, you are able to lift it because it immediately acts like an electromagnet. You switch it off, the thing will fall down. You lift it from here, you want to put it there. What you do essentially, Switch it on, you lift it, you put it there, you switch it off, it will release, and the whole thing will fall in the other place. Simple, right? So when the current is turned on, the electromagnet lifts the iron or the steel objects. When it is switched off, the magnetic field disappears and the objects are released. Pretty simple. The illustration makes it very easy for you to understand, which is why I prefer to teach like this instead of teaching you only with the help of the NCERT book, because I am not a great fan of the way the NCERT books are structured. Some of the things obviously we have to refer to it, especially when it comes to the activity. But apart from that, I prefer to teach it with the help of these colorful illustrations, so that you also feel interested and there is a sense of participation. Now, lifting electromagnets are widely used where? In factories, scrapyards to move. Scrapyards are where all this kind of different scrap material are there, discarded things. So you want to lift it, put it, you want to dispose of those goods. So you do that to sort, etc. You use the electromagnet effect effectively. Okay, now let's move to the next part, which is the heating effect of electric current. Now, what exactly are we talking about here? The core principle of the heating effect of electric current is that magnetism is over. Now we're going to talk about the heating effect. That the electric current faces resistance inside a conductor. This converts, we will study about this in more detail in class 10. This converts electrical energy into heat energy. Now, when electric current flows inside a wire, okay, I'll tell you, for example, if the AC is not on and we are in peak summer, I realize that my laptop gets heated up, right? What is happening? Because when the electric current is passing through my laptop, when it is switched on and I'm working, if I have not switched on the AC, the room is getting stuffy. It doesn't happen in winter months, but in summer, it gets heated up because the atmosphere is also pretty warm. So electric current faces resistance inside a conductor, inside the wires that are going inside the laptop, etc., the charging which is taking place, etc. This converts the electrical energy that is being fed inside into heat energy, and the device gets a little heated up. That's a core principle. So what are the factors which affect heat, in the sense that the electrical energy getting converted into heat energy? First is the material of the wire. What material you are using? If the material is not strong enough, that is likely, or if the wires are very thin and not thick, they are likely to get heated up much more and much faster. So the material of the wire plays an important role. Then the second factor which affects the heat is the thickness of the wire. How thick it is. What is the material, what it is made of. Number two, the thickness of the wire also plays an important role, which I just now told you. The third is the length of the wire. If the wire is very short, it is likely to get more hot compared to a wire which is long. It's as simple as that. Think of it like this. There is a passage, right? And a lot of people are going through. If it is a short passage, a narrow passage, right, or the length is not much, the passage length is not much, you are likely to face a lot of overcrowding. A lot of overcrowding, what means what? A lot of carbon dioxide will get released. The whole place will feel very stuffy. Whereas if you have a long passage through the same number of people, through which the same number of people can travel, so there is distance between them, you will not feel very stuffy. The same funda, the same principle is being used here. I hope it is clear with the help of this example that I've given. Then the magnitude of current, how much of current is passing through that electrical wire, that also affects the heat. So if you have this much of current passing, everything is cool. But if you have more current passing, you realize that there is too much of stuffiness, and that leads to this getting more and more hot and red. Then the duration of the current flow. How long are you kind of having it? For example, if you leave your mobile on charge, okay, it has got 100% charge, but you have left it on charge, which means the current is continuing to flow. In more cases than one, you will find that the mobile has got a little hot, because you are actually, the duration of the current flow has been for longer than is necessary. Then the heating element. Now the heating element, let's talk about a wire or coil designed to become hot. Now, if you see an immersion rod, I don't know if you have ever used an immersion rod, ask your parents, they would have used it, or ask your grandparents, they would have used it, right? I don't have it at home here. My daughter, when her solar geyser was not working at her hostel, she had temporarily bought an electrical geyser, which is immersion rod, which is never a very safe kind of thing, because if you touch the water through which current is passing, you can get an electric shock. So not advisable at all. So you will find it has that heating kind of element, it has the heating element. Or if you see, if you live in the northern part of India, during winter months, you would be using the heat convector or some kind of a heater, right? Now that also gets hot, right? And through which you get the heat. So these are known as the heating element, a wire or coil designed to become hot, which is why written in red. So it is generally in this kind of a shape. So applications where it is used, it is in heater, what I told you. Stoves, it is used, the old time stoves, there used to be this kind of a coil which would get hot if you don't have a gas at home, and you put your water, milk, whatever, and you can cook there. Kettles, irons, okay, irons like this, right? Immersion rods, what I just now told you. Then these blow dryers, the hair dryers, the lamps, etc. These are all using the principles of the coil. For example, even inside the bulb, which is of course the filament, but essentially we are talking about some kind of a heating element which is also getting hot as a result of the passage of electricity. Now you have to take care of the safety issues, right? Unwanted heating can lead to energy loss. That is, you are kind of wasting electricity if you're just kind of letting it get wasted as heat energy. Electrical energy, it is light it may be providing, but heat energy sometimes it is a wasted kind of an energy. Then overheating may melt plugs. That can always happen. Sometimes it can, if too much of electricity. For example, I found in one of my parents rooms, the 15 amps switch was not there, so we could not connect it to the air conditioner. It had only a 5 amps ka switch, which is used for electrical iron and toaster, etc. kind of things. You cannot use it for a microwave, you cannot use it for an air conditioner. But by chance, if I insist and say ki lagao, what will happen is that the wires will not have the strength to take so much of current. So when that does not happen, the entire plug can completely melt and it can lead to a short circuit also. So overheating because of overheating. Overheating may melt plugs or cause fires. Safety devices are used to reduce risk. You will study about MCBs, or the miniature circuit breakers, which is called miniature circuit breakers, which looks a bit like this. You will again find this in your home. Please go and look for the MCB box, and you will find something like this with a switch like this, which is used to break the circuit in case of overheating. So these are all the safety devices. We'll study about MCBs in class 10 syllabus in physics. Okay, so I hope till here it is clear. Now let's now move to the next part, which is talking about the world of batteries. Now, generation of electricity by batteries. The definition is a battery generates electricity through chemical reaction. Now here we talked about heat energy. Now let's talk about something related to chemistry. So what happens is that inside this battery there are chemicals which help you to generate electricity, because not always you will have raw power, right? You will not have a direct power connection. So sometimes you need to use batteries in order to kind of go on. It's like this, sometimes you don't have Wi-Fi connection anywhere, so you need to use the mobile data, but your laptop may not be having a dongle or anything, so you give the mobile hotspot from your mobile phone in order to connect the laptop, right? We all do that, right? So this is something like that. This is the alternative to raw power, raw current. So what happens in this case? Now, this is a very interesting thing called the voltaic cell, which is also known as the galvanic cell. Let's explore how chemical energy becomes electrical energy. How does this entire process really happen? Now, what happens is that there is a whole lot of electrolyte, zinc, copper, different things which are involved in this entire process. So its structure contains electrolyte. Okay, in fact, I think in the book maybe explain more. Let me just check quickly with the book. कि जब तक आएगा बुक में से देख लेता हूँ. Okay, this is on page 55. Let me just see if it's required or not. I think I'll go directly to this only. Okay, so its structure includes an electrolyte, two metal electrodes. Okay, two metal electrodes. ये पानी नहीं है. This is an electrolyte in which you put two metal electrodes, right? And the function is that chemical reactions produces electricity. So when they get together and they are connected, it can actually produce electricity. Okay, so if you see on page 55, how does a battery generate electricity? It contains two metal plates made of different materials and a liquid which is known as an electrolyte. It is placed in a container. Now, the plates called electrodes are partly dipped in the electrolyte, which is usually a weak acid or a salt solution. And then what happens is a chemical reaction inside this, the electrolyte and the two metal plates which are put. So current flows from the positive to the negative terminal. Okay. And when chemicals are exhausted, the cell becomes dead. When the entire chemicals get exhausted, it becomes dead. So a chemical reaction between the plates and the electrolyte produces electricity. So the electrolyte and the two metals together, they produce the electricity. When the circuit is connected, electric current flows from the positive terminal to the negative terminal, and over a period of time, the chemicals get exhausted, the cell becomes dead. Now, let's understand the history of this, which is quite a fascinating story. Now, it is named after Alessandro Volta and Luigi Galvani. Okay, that's how the name also came, the Voltaic cell or the galvanic cell. Now, what exactly did these two gentlemen do? In the late 1700s, Galvani noticed that a dead frog's leg kicked when touched with two different metals, copper and iron. So if a frog, एक मेंढक मर गया है, a frog is dead, but if the leg was touched with either copper plate or an iron plate rod, it actually kicked, the leg clicked. So they were very surprised as to why something like this is happening. Okay, so then Galvani saw the frog's leg twitch and thought that the frog was like a battery that stored a special kind of life force or electricity in its tissue. So he was very foxed. He didn't understand. So he kind of thought, imagined that it would be something like this which would be happening. But he thought that the metal wires were just the pipes, the two metals, the copper or the iron. They were just like the pipes that let the frog's own electricity flow out. That is, the frog is having electricity and it is flowing through the metals, the iron or the copper metals is what Galvani thought. But Volta had a bit of doubt. He suspected that the frog was not the source of power. The frog is dead. How can electricity be generated from the frog's leg? So he said that it was actually a reaction to electricity created by the metals, either iron or copper. So Galvani's idea was this, that it was the frog's leg which was creating electricity, whereas Volta's idea was that copper and iron were responsible, and that is what was leading to this kind of a reaction from the leg of the frog. Okay, so this was the difference, and I hope you are able to get the difference. So then Volta replaced the frog's leg with salt water soaked paper, and the result was that electricity still flowed. So it had nothing to do with the frog. It had nothing to do with the leg of the frog. But if you had a salt water soaked solution, which is why you can do it even with lemon like water, you can actually generate the same kind of an effect. The electricity still flowed. So this proved that you did not need a living thing or a frog's leg to create current. You just needed two different metals which would act like electrodes and a conductive liquid, electrolyte, okay, like salt water or frog juice. So electrolyte was a conductive liquid like salt water, electrodes which are two different materials like iron or copper, and you can actually generate electricity as a result. So based on this, Volta built a stack of alternating zinc and copper discs separated by salt water soaked cardboard. This provided the world's first steady source of electricity. So this, when he prepared this, this became a bit like a battery, which is like you can take it around and you can generate electricity without having any of the other sources, right? So this was a major invention at that time. Now, let's move to activity 4.6. Activity 4.6 is on which page? Oh no, I've gone too ahead, sorry. 4.6 is activity 4. Okay, activity 4.6 is before this. Yeah, it's very fascinating. Activity 4.6 is very interesting. And this is something which you should definitely do in your school laboratory. Please ask your teacher to do this. So what you need to do is to take about 5 to 6 nimbus. Okay, घर से नींबू लेके जाओ, copper wire लेके आओ from the laboratory, and iron nails. Also take one LED and some connecting wires. So you connect the wires like this, right? On each nimbu with a nail, you put it and you connect the wire. You can see that the wires are all connected, and you connect it to an LED bulb, right? So what you do as a result, what you see out here is that when it is all connected like this with the copper wire, and these are the 5 nimbus, the LED will actually glow. So the glowing LED indicates that your cell is working. In the cell, the metal electrodes are the copper wires and the iron nails. These are the iron nails, okay, and these are the connecting copper wires. So the electrolyte is the nimbu, lemon juice inside that, which helps conduct electricity. You can also use salt solutions instead of lemon juice, right? So this is very interesting, very fascinating. This is an experiment which you should definitely try at school. So it shows that the LED glows because the metal electrodes are the copper wires and the iron nails. Okay, so the copper wires and the iron nails are actually acting as the electrodes, metal electrodes. So the electrolyte is the lemon juice which helps conduct electricity. With salt solution instead of lemon juice will give us the same result. Okay, you can use instead of lemon juice even salt solution. So next we move to what are dry cells. Okay, we have studied till the electrolyte, but it was obviously not something which you could have used. You cannot carry the liquid electrolyte everywhere. So what is it? So that's where the dry cells got invented. Because voltaic cells were not convenient to use or to transport or to carry, the world moved to the dry cells. Now, they are called dry cells because the electrolyte is a moist paste, okay, not a liquid, as in the case of the electrolyte. Electrolyte is a liquid, right? Like salt water solution is a liquid. But here what we are using is a moist paste, which is why it is known as a dry cell. The structure is a zinc container, which is a negative terminal. This is the structure of it. Then you have a carbon rod inside it, which is the positive terminal. So you have negative as well as positive terminal inside the dry cell. The carbon rod, if this is the carbon rod, it is surrounded by the paste-like electrolyte. So it is not a liquid, it is a thick paste-like thing which surrounds the carbon rod. Okay. The dry cell is a single use, that you use it for a single time, it gets discharged, you need to throw it out. So it's a single use cell, what I told you. Once it is used, it has to be disposed of, okay, in the battery recycling pack. Then you have the rechargeable batteries, like what I told you, what you use in your inverter, what you use in your mobile phone batteries. They can be recharged and used several times, okay. So they have a longer life. So it is a money saver, plus you are not discarding it into the environment. I mean, you're not just throwing it, at least not immediately, whereas these ones will survive for a month or 2 months depending on the usage, right? So these are used in watches, in phones, in inverters, in electric vehicles. Like in electric vehicle, the battery that you have in your car or in your bike, that is a rechargeable kind of a battery. I mean, it will end one day, but it will still be a longer life. Then you have the lithium ion batteries, which is what most batteries are being used now. Most common modern rechargeable batteries are the lithium ion batteries. Future technology, what will happen is that there will be solid state batteries, use solid electrolytes instead of this moist electrolytes. Also they will use solid electrolytes. That is going to be the future of these batteries. They are safer and they charge faster as well. E-waste and recycling. Now this is again something which you have to be very careful about, that you cannot just dispose of the batteries into the environment along with normal kitchen waste. No, you need to dispose it off in a responsible manner. The e-waste, there are the e-waste recycling plants. So dead batteries contain harmful and valuable materials. So therefore you need to be very careful and responsible in the manner in which you dispose of old mobile phones or any of the old batteries. So if you are buying a new battery, for example, an inverter battery needs to be changed every 3 to 4 years. So you get the person, you buy the new battery, you give it to the person so that he will be responsible for disposing it off in a proper manner, not just throw it with the regular garbage. So they should be disposed of through e-waste recycling facilities. This is again something very important. The e-waste recycling, there are a whole lot of companies which are there entirely in the business, in the trade of e-cycling, e-waste recycling. Okay, so this is what is very important, and as young citizens of this country, you need to be aware of something like this. With this, we come to the end of this chapter. As I say, share the videos, subscribe to the channel so that ours can be one of the most vibrant and large communities catering to class 6, 7 and 8 students out here on CBSE. I will do a separate video on the test paper. I will create some questions. I will include some questions from your textbook. But essentially, that's the kind of video you should see before you go to the examination so that you are fully prepared to answer any question. And how did you get a 50 on 50? Because you are students studying out here at CBSE. Tata, bye-bye. Thank you very much. Namaskar.